Have you ever wondered how electricity flows? It's something we use every day, but rarely stop to think about. From the moment you flip a light switch, a fascinating journey begins. It's like a hidden river of tiny particles called electrons. These electrons are the heroes of our story, constantly moving and creating the energy we rely on. These electrons are super small, even smaller than you can see with a microscope. Imagine something so tiny yet so powerful that it can light up entire cities. Conductivity is the word we use to describe how easily these electrons can move through different materials. It's a crucial concept in the world of electricity and electronics. Think of it like a water slide. Just as water flows down a slide, electrons flow through materials. Some slides are super slippery, and you zoom down really fast. This is similar to how electrons move through materials with high conductivity. That's like a material with high conductivity. In these materials, electrons can move freely and quickly, making them excellent conductors of electricity. The electrons can zip through easily. This is why materials like copper and silver are used in electrical wiring. They allow electricity to flow with minimal resistance, but other slides might be bumpy or sticky, slowing you down. This is what happens in materials with low conductivity. That's like a material with low conductivity. In these materials, electrons face more obstacles and can't move as freely. The electrons have a harder time moving. This resistance can cause energy loss in the form of heat, which is why poor conductors are not ideal for electrical wiring. Understanding conductivity is super important because it helps us make all sorts of cool things, like phones, computers, and even spaceships. By mastering the flow of electrons, we can create more efficient and powerful technologies that drive our modern world. Conductors are the superheroes of the electrical world. They play a crucial role in our everyday lives, making sure that the electricity we rely on can travel from one place to another efficiently. Without conductors, our modern world would come to a standstill. Imagine a day without your phone, computer, or even the lights in your home. That's how important conductors are. They are like the super slippery water slides for electrons. Just as water slides allow water to flow smoothly and quickly, conductors allow electrons to move freely and efficiently. This movement of electrons is what we call electric current. Conductors have lots of free electrons that can move around easily, letting electricity flow through them smoothly. These free electrons are not tightly bound to atoms, which means they can move around and carry electrical energy from one point to another with minimal resistance. Many metals are excellent conductors due to their atomic structure, which allows free electrons to move easily. Metals like copper, silver, and gold are excellent conductors. Copper is widely used because it is both highly conductive and relatively affordable. Silver is even more conductive than copper, but it's more expensive, so it's used in specialized applications. Gold, while also a great conductor, is primarily used in high-end electronics due to its resistance to corrosion. That's why we use copper wires in our houses to carry electricity. Copper's excellent conductivity and durability make it the perfect choice for household wiring, ensuring that electricity can be safely and efficiently delivered to all our appliances and devices. Water is also a good conductor, but don't worry. The water in your bathtub is safe because it doesn't have any electricity flowing through it. Pure water is actually a poor conductor, but the minerals and impurities in tap water can conduct electricity, unless you drop a toaster in there. Just kidding, don't do that. Always remember, electricity and water can be a dangerous combination. Safety first. Now imagine a slide covered in bubble wrap. You might think it would be fun, but when you try to slide down, you quickly realize it's not as easy as it seems. The bubble wrap creates a lot of friction, making it difficult to move smoothly. This is because bubble wrap acts as a barrier, preventing easy movement. It would be pretty hard to slide down, right? This is a great way to understand how insulators work. Just like the bubble wrap stops you from sliding easily, insulators stop electricity from flowing freely. Insulators are materials that don't let electricity flow through them easily. They are essential for electrical safety, preventing shocks and short circuits. They ensure electricity goes where it's supposed to and doesn't cause trouble. Without insulators, the electrical world would be chaotic and dangerous. Insulators are found in almost every electrical device and system, from small gadgets to large power grids. They are crucial for safe and efficient operation. Think about the rubber coating around electrical cords. Rubber is an insulator that prevents electricity from escaping the wire and causing harm. It prevents shocks, making proper insulation on all electrical wires and devices essential for safety. Other examples include glass. used in high-voltage applications, and plastic, which is lightweight and versatile. Even wood can be used in certain situations. Insulators come in many forms, each with unique properties and uses. Now, for the really cool part, semiconductors are like the shape-shifting wizards of the electrical world. They can act like both conductors and insulators, depending on how we treat them. It's like magic, but it's actually science. Silicon, the material used to make computer chips, is a semiconductor. By adding tiny amounts of other elements, we can change silicon's conductivity and make it switch electricity on and off really fast. This is how computers think and remember things. Conductivity is everywhere in our daily lives. Remember those copper wires in your house? They carry electricity from power plants to your home, allowing you to turn on the lights, watch TV, and charge your phone. Think about your phone again. It's full of conductors, insulators, and semiconductors all working together. The battery uses conductors to store electricity and semiconductors to control its flow. Insulators protect the delicate circuits inside from damage. Conductivity powers our modern world. Engineers use their understanding of conductivity to design all sorts of amazing things. They use conductors to build powerful motors that drive electric cars and airplanes. They use insulators to create protective gear for electricians and create safe environments for working with electricity. And of course, semiconductors are at the heart of all our electronic devices, from smartphones and laptops to advanced medical equipment and space exploration robots. As we learn more about conductivity, we can create even more incredible technologies. Scientists are working on new materials that conduct electricity even better than ever before. Imagine super-efficient solar panels that can power entire cities or super-fast computers that can solve the world's biggest problems. Now let's go through important terminology that we just explored in this video. Conductivity, how easily electricity flows through a material. Electrons, tiny particles that carry electricity. Conductors, materials that allow electricity to flow easily. Example, copper. Insulators, materials that resist the flow of electricity. Example, rubber. Semiconductors, materials that can act like both conductors and insulators. Example, silicon. Now let's talk about PCBs. Printed circuit boards, or PCBs, are the backbone of modern electronics. They serve as the platform where conductive and non-conductive materials work together to make our devices function. First, a thin layer of copper is laminated onto a non-conductive substrate, often made of fiberglass. This copper layer is then etched away to create pathways for electrical currents. These pathways are like highways for electrons, allowing them to travel efficiently between different components. Next, holes are drilled into the board for component placement. These holes are often plated with conductive materials to ensure a strong electrical connection. Finally, the components are soldered onto the board. Solder, a metal alloy, melts at a relatively low temperature and solidifies quickly, creating a secure bond between the components and the PCB. In essence, PCBs are a fascinating blend of conductive materials like copper and solder, and non-conductive materials like fiberglass and epoxy. This intricate dance of materials makes all our electronic gadgets possible, from smartphones to supercomputers. Understanding how PCBs are made not only gives us insight into the world of electronics, but also opens up endless possibilities for innovation and creativity. So next time you use an electronic device, remember the complex yet elegant structure that makes it all possible, the PCB. The world of electricity is full of exciting discoveries. Keep asking questions, exploring, and experimenting. Who knows what amazing inventions you might create by understanding the power of conductivity?